right, today we're talking about the logistic growth model. So we start with differential equation, separable, and then in general, and then we saw the exponential growth model, which follows a differential equation of the form dy dt is equal to k times y. Solution there we saw is y is equal to some y initial e to the kt. So this is an exponential growth model. It just goes off and off and off. Now, while many things follow an exponential growth model at least some of the way, nothing follows it, or I should say nothing based in reality follows it completely, because otherwise you would end up tending towards infinity with all your populations. In the real world, most things follow what is known as a logistic differential equation. And in a logistic differential equation, you can see one right here, dy dt is equal to ky m minus y. So what you see here is the ky is the same, but then there's this additional factor of m minus y. So in this differential equation, as y gets bigger, y is the population. As y gets bigger, ky gets bigger, which means the derivative gets bigger, which means the population grows faster and faster and faster. Y gets bigger, derivative gets bigger, and so on and so on. Well, what happens in a differential equation is we have something known as the carrying capacity. Think of that as the maximum that the population can reach. Now, why would there be a maximum? Well, think of, say, animals in an environment. You can't have an infinite number of rabbits living in a park, because there's competition among the rabbits, there's predators, there's a lack of food, there's only a finite amount of food. So generally in an environment, there's what is known as a carrying capacity. It is the maximum population that the environment can sustain. So if you think about, if you start with a population that is below the carrying capacity, then the quantity m minus 1, if the population y is less than the carrying capacity, then we have a positive quantity and my derivative is positive and the population grows. So this is growth. Once the population reaches the carrying capacity, the derivative goes to 0, because this quantity is now 0 and we have no growth. If somehow the population were to go greater than the carrying capacity, either you can imagine there's an environment where only 100 squirrels can live and we introduce 200 squirrels. Well, then what will happen is the quantity m minus y is therefore negative. Thus, the derivative is negative, and we have decay of the population. When you look at the solution to a logistic differential equation, what you see is something that looks much like exponential growth in the beginning, but then begins to taper off and approach that carrying capacity of m. So as time goes by, the population grows, and slowly and then quickly, but then at some point, as that population reaches near the carrying capacity, the population is going to begin to slow its growth and arrive at equilibrium at the carrying capacity. If we had a situation where we introduced, bells ringing. If we had a situation where we introduced a population greater than the carrying capacity, you would just see a decay down to the carrying capacity.